Welcome, everyone, and thank you for joining me today. I'm Dr. Sukhdev Singh, and today I will talk about forensics of knowledge, the second opinion layer in the era of generative AI. Here's the thing, every fingerprint has a story. It shows where someone has been, what they've touched, and whether they can be trusted at the scene. Information works the same way. Every claim, every citation, every AI-generated answer carries traces of its own origin, and our job as information professionals is to read those traces before we pass anything along as fact. Over the next several slides, we are going to walk through why generative AI has made this detective work more urgent than ever, and why libraries are uniquely positioned to be the forensic lab knowledge now needs. Let's get into it. So let's start with something important to get straight. AI didn't invent the problem of made-up information. Humans have always fabricated, exaggerated, and gotten things wrong. What AI did was industrialize it, take a problem that used to happen slowly, one error at a time, and scale it to machine speed. Look at this contrast on screen. On one side, the confident machine, it produces text, summaries, and citations in seconds, and its answers are fluent and self-assured enough to pass a surface-level glance, even when they're completely synthetic. On the other side, the hesitant human, someone who pauses, who double-checks, who invites scrutiny precisely because they're not sure. Here's the uncomfortable truth. A hesitant answer gets questioned, but a confident one gets passed along. Without independent verification, that confidence becomes instantly baked into our knowledge ecosystem. That's exactly the gap we need to close. Now let's talk about something that should genuinely concern every researcher and librarian in this room, the citation feedback loop. Researchers tested GPT-4o's citation behavior against a pool of 10,000 scientific papers, and the results are striking. 90% of the references the model generated came from just the top 10% most cited papers, and 60% came from the top 1% alone. Only about 8.5% of those citations actually appeared in the real reference list of the corresponding paper, which tells us the model is recognizing patterns, not copying directly. But here's the real danger. The AI favors recent publications, shorter titles, smaller teams, and prestigious journals. That means niche research, regional scholarship, and early career voices get starved of visibility. An AI-generated citation can be entirely relevant and still be deeply biased, and that bias compounds every time someone trusts it blindly. Here's a distinction I want you to really sit with. Retrieval is not the same as provenance. When you pull up an article, you might think you've found the source, but an academic article isn't a single, fixed object. It moves through stages: a preprint, an accepted manuscript, a version of record, and sometimes, eventually, a retraction or correction. When AI cites a paper, it rarely verifies which version it's actually pulling from. If the model retrieves an outdated or incorrect version, maybe one that was later retracted, the answer it gives you will still sound completely convincing. That's the trap. Simply knowing the source is no longer enough. We have to know the source's entire history. This is precisely the kind of version tracking discipline that librarians have practiced for decades, and it's about to become far more valuable than most people realize. Let's shift gears and talk about a cost that rarely makes headlines: the hidden cost of machine-scale access. Automated AI crawlers are hammering digital heritage infrastructure at a scale it was never built for. A GLAMI Lab survey of 43 cultural institutions found that 39 reported increased website traffic, and 27 said that AI training bot traffic surges were directly forcing parts of their collections offline. That's real institutional strain, borne by libraries and archives that never signed up to be data farms. And it goes further. Anna's archive has reported that commercial entities are buying up physical books purely for mass scanning, and in some cases destroying the physical copies afterward. So ask yourself this: what happens when a digital copy sits locked away on a private server, and the physical original simply no longer exists? Who bears the cost of the open web when machines become its heaviest users? So here's a connection I find genuinely energizing. Forensic science and library and information science are, at their core, the same discipline applied to different subject matter. Forensic science asks, is this physical evidence real? It deals with synthetic evidence like deepfake video and fabricated voice recordings, and it follows physical traces back to their origin. Elias asks a parallel question: is this knowledge claim real? And it deals with its own synthetic evidence, from AI-generated citations to fabricated findings, following citation traces back to their source. Both fields share the same guiding rule, which I like to call Locard's exchange principle for data: you do not accept what is presented to you at face value. You trace it, you verify it, you authenticate it, and you establish provenance before you ever extend your trust. That mindset is the whole foundation of what comes next. Medicine already solved a version of this problem, and we'd be wise to borrow its solution. Think about it this way: AI produces, but it does not independently verify. On one level, we have the diagnosis, or machine output, lightning fast, hyperfluent, delivered with high confidence, but with unverified sourcing and a real susceptibility to the bias we just discussed, sometimes called the Matthew effect. On the other level, we need the second opinion, an information professional verifying that output, stress testing it, checking its provenance, staying culturally sensitive, contextually accurate, and bias-aware. Peer review exists in academia, appeals exist in law, audits exist in finance. Every serious system builds in a mechanism to catch errors. A reliable system isn't one that assumes the first answer is correct, it's one built to find out when it's wrong. That's the second opinion layer libraries need to institutionalize now. Let's get practical. How exactly do libraries anchor researchers in this new landscape? I want to walk you through 5 concrete roles. First, understand AI. That means actively evaluating confident but inaccurate answers and recognizing bias before it spreads. Second, provide training, and this one matters, because only 45% of over 3,000 researchers surveyed said they have adequate access to AI training. Third, shape policy, yet only 32% of researchers believe their institution has good AI governance in place, which tells you there's a real leadership gap to fill. Fourth, recommend tools, separating genuinely high-value resources from the ones that just create confusion. And fifth, support collaboration, helping the 68% of researchers now reporting increased interdisciplinary work. AI changes the tools, but evaluating information has always been the library's domain. Now here's a framework I find genuinely useful for thinking about how students actually engage with generative AI. Picture to access, AI input, ranging from simple to iterative, and cognitive output, ranging from surface to deep learning. In a survey of over 1,000 students, we consistently see moderate trust in GenAI, but its real value depends entirely on the cognitive workflow being used. Down in what I call the danger zone, students are just typing a question and grabbing the answer. Limited learning happens there, and the risk of hallucinated content going unchecked is high. But up in the target zone, students are questioning and reflecting, discussing ideas, comparing explanations, identifying gaps, improving their own text. So the real question isn't whether students should use AI at all. It's how we teach them to use it in ways that actually strengthen their own thinking. Let's talk tools, because no single AI platform does everything well, and the real skill is matching the right tool to the right context. Picture a simple grid. One axis runs from everyday reasoning to deep research, the other from synthesis and drafting to provenance and verification. In the everyday reasoning and drafting corner, you've got Claude and ChatGPT, excellent for literature synthesis, drafting, and working through long documents. Move to deep research and drafting, and Semantic Scholar paired with Zotero or Mendeley shines for scanning new research areas, managing references, and catching duplicates. For quick, cited, web-grounded answers at the reference desk, reach for Perplexity or Google Gemini. And for the heaviest verification work, systematic reviews, extracting findings across large collections, checking whether later research still supports earlier claims, that's where consensus, illicit, and cite earn their place. Match the tool to the task, every time. At some point, we have to stop philosophizing and just try things, so here's a simple 3-phase workflow for bringing AI into library operations. Phase 1 is input and organization. Use Claude to draft MARC records straight from book covers or ISBNs, then verify against WorldCat, and apply AI-assisted OCR to small, difficult scanned collections to measure your error rates. Phase 2 is process and analysis. Build chatbots to handle circulation questions like fines and renewals, use Cite for citation checking in promotion files, and lean on illicit or consensus for complex literature support questions. Phase 3 is output and access. Implement natural language search in your OPAC to finally move beyond rigid Boolean queries, and automate metadata entry with Zotero for reference management. My advice? Pick one backlog, try one tool, keep the human verification step firmly in place, and see what breaks. Institutional trust doesn't happen by accident, it has to be deliberately built, and it rests on 3 pillars. The first is scholarly IP and licensing, giving researchers clear guidance on their rights when their content gets pulled into AI training, and integrating copyright and licensing directly into institutional AI policy, following models like MIT's. The second, sitting right at the center, is authenticity R&D, testing how our existing provenance practices hold up against the sheer speed of AI transformation, and pushing for open, vendor-agnostic approaches to provenance data, the way the Library of Congress has championed. The third pillar is open collaboration, institutions sharing their experiments, their failures, and their tools rapidly, bypassing the years-long traditional scholarly publication channels that simply move too slowly for this moment. Securing scholarly content and digital provenance takes all 3 working together. So let's bring this all together. The second opinion saves lives in medicine. It protects rights in law. And in an AI-assisted world, it protects the integrity of knowledge itself. Here's the line I want you to carry out of this room: AI can verify technical facts, but it cannot replace human judgment about meaning, context, intent, or truth. The role of the library has not changed. What's changed is the stakes, and they have never been higher. Thank you so much for spending this time with me today. If any of this sparked a question or a disagreement, I genuinely want to hear it. That's how this field moves forward. Do subscribe if you'd like more lectures like this one, and if you are a library or information professional, I'd love for you to join our AI4Lib community on WhatsApp, where these conversations continue every single day. Until next time, keep tracing the evidence.